Today, we will start very interesting topic called influence line or influence lines for beams. Actually, we should learn influence lines for frames, for trusses, but in this course, that's enough to learn what is the meaning of influence lines for beams. Before starting, what we learned before, we have a beam looks like this, and we have here a concentrated load, for example, with 12 kip. We learned that we have two reactions at this hinge and one reaction at this roller. The horizontal reaction will be 0. Probably the vertical reaction will be 8. The vertical reaction here will be 4 kips. I'm assuming numbers. So what is the problem or what is the topic today? What we learned before, this beam and this concentrated load and these reactions are constant forever. I'm sorry, what you mean by constant forever? I mean the value for this concentrated load 12 will not be changed. The location for this concentrated load will be at this specific location, no change. That means this reaction will be 8 and this reaction will be 4 forever. No change. What is our topic today? Today, I will talk about something completely different. We have a beam, but this beam is a bridge. We have here water canal. So we have bridge connecting between the two sides. So actually this bridge looks like a beam as a structure analysis, supported on this side and supported on the other side. So this bridge looks like this beam. What is the issue? The issue is, what is the main function of this bridge? Do you know? What is the main function? I believe the main function of any bridge to carry moving loads. Moving loads, it's a new term, moving loads, or to carry trucks. Okay, what is the problem? No, we have a big issue here. Because this truck, which looks like this truck is moving. I'm sorry, what you mean by moving? I mean sometimes this truck is here. So assume the weight of this truck to 20 kib, for example. So at a certain instant or a certain second, this truck at this location. So we have reaction. Probably this reaction is 15 and this reaction is 5. After probably less than 1 second, after 1 second, this truck moved to this position. So we don't have this one right now. So I believe the new position of this truck will change this reaction to be, for example, 10, and this reaction will be 10. After another second, the truck will move more. So these reactions will be changed, probably 15 and 5. So our topic today is talking about something new. We are talking about bridges. What you mean by bridges? I mean, we have beams, the same beams, supported by hinge or roller. Nothing changed. But the main difference right now, this bridge is supporting something called moving load. These moving loads are considered like trucks, like cars, like vehicles. All of these moving loads are moving on the beam. What is the problem? The problem, if you have a moving load, we have variable reactions, not only one reaction. This reaction will be changed by changing the position of the truck. Anybody, did you learn what is the meaning of influence line? This part is very important. We need to understand, we need to be familiar what is the meaning of influence lines for beams. Beams are the same, nothing changed. We have a beam, we have hinge, we have roller. But the only difference right now, this load is variable in value and position. Value, are you sure? Value would be variable? Yes, I'm sure. Sometimes we have truck like this. Sometimes we have truck like this. Sometimes we have truck like this. Sometimes we have bus like this. Do you think the value of the weight or loads coming from these trucks will be the same? I don't think so. So we have variable values and also variable positions. The position of this load is moving on this bridge. So what is the effect? What is the influence of these loads on reaction? This effect can be considered influence lines. Influence lines. Any question? Guys, this part or these few seconds are very important to understand what is the meaning of influence line. Any question? Do you have any question? Let me know. It's very important to understand what's going on in this part. If you can understand this part, because this part is more advanced a little bit, it's related to bridge engineer. So if you can understand it, you are in a good position. To make sure you understand this part more and more, okay, let's start to watch this video to understand it more and more.
Reaction influence line for statically determinate beams. Suppose we are asked to design column BG in this bridge. In order to...
So we have a bridge. We have a bridge. And we have piers or supports. Please pay attention.
Correctly design the column, we first need to determine the maximum axial force that it will be carrying. This means we need to calculate the maximum support reaction at B. I say maximum because here the support reaction is not constant. It changes as the load moves across the bridge. We can determine this maximum force with rather ease by drawing what is known as an influence line.
So guys, can you watch what's going on when the car is moving? This car is moving from the left side to the right side. We are focusing only on reactions at B. Can you see what's going on with reaction at B and the moving of the car? One more time.
Load moves across the bridge.
The value of the reaction is variable because the car is moving.
We can determine this maximum force with rather ease by drawing...
That makes sense? One more time, this video is very interesting. The car is moving, so the reaction at B is variable.
Because here the support reaction is not constant. It changes as the load moves across the bridge. We can determine this maximum force with rather ease by drawing what is known as an influence line. An influence line is a diagram. It shows how a specific force in the structure changes due to a unit moving load. Here is the influence line for reaction at B.
Wow, this diagram is called influence line for reaction at B. So this whole diagram only for reaction at B when the car is moving from this side of the bridge to the other side. We need in this part of the course to understand what is the meaning of this diagram. How can we draw this diagram? But before learning this, how to draw this diagram, I would like to repeat this video one more time. Please understand what is the meaning of reaction at B when the car is moving from this side to the other side. What's going on with reaction at B? One more time.
Correctly design the column. We first need to determine the maximum axial force that it will be carrying. This means we need to calculate the maximum support reaction at B. I say maximum because here the support reaction is not constant. It changes as the load moves across the bridge. We can determine this maximum force with rather ease by drawing what is known as an influence line. An influence line is a diagram.
So influence line is a diagram. Influence line is a diagram. We need to draw this diagram. Okay? Some information. Influence line represents the variation. Why variation? Because we have moving load. The value and the position of this load is variable. So we have variation of reaction, not reaction only. Because if you have variable reactions, you will have variable shear, you will have variable moment. That makes sense? Previously, we learned from reaction, we can calculate shear. From reaction, we can calculate moment. If you have variable reaction, you will have variable shear and variable moment. Everything is variable because the load is moving. And also variable deflection, but we didn't cover this until this moment. At a specific point in a member, as a concentrated force moves over the member. Anyway, influence lines represent the effect of moving load only at a specified point. The video was showing reaction at B only, one specific point, reaction at B. And the car is moving from this side to the other side. So we are taking the influence line due to the effect of moving load only at a specified point, specific point. Anyway, once the influence line is drawn, when we can draw influence line, believe me, we can determine what is the worst case of the moving truck. Therefore, influence lines are very important in the design of structure. Which structure? Your building, your house, your apartment, our university, campus. What are the structures that we need to construct influence lines? Structures that have moving load. I understand you are a person, you can move from the kitchen to the bedroom, but I'm so sorry to say this, but you are nothing. What is your weight? 200 pound? 150 pound? 250 pound? You are nothing. I'm talking about cars. I'm talking about trucks. The weight of these trucks, something around 5,000 or 50,000 pound. So you are nothing. 200 pound is nothing. You are not a moving load. I'm talking about trucks. So structure where the loads move along the span, like bridge, cranes, something like this. Mainly bridges. Okay, so I can understand right now. I have bridge between this side and this side, and I have moving load. I can understand this exactly. This truck is moving, so the reaction at this location is variable. That makes sense because the position of this truck is moving. But I have a big issue. Do you think I need to solve this problem for many times? I'm sorry, what you mean by many times? I mean, sometimes we have this truck with 1, 2, 3 axes of loads, 3 wheels or 3 axes of wheels. Sometimes we have bigger truck like this one, 1, 2, 3, 4, 5. Sometimes the truck looks like this one. Sometimes the truck looks like this one. Sometimes I have a small truck or a small car like this. So which car? Sometimes we have train. Probably. Which car I'm gonna use to solve our structure? Do you think which one? Any answer? Any answer? Anybody can tell me which car, which truck? What do you think? Which one I will use? Do you think I will use the biggest one or the smallest one? What do you think? Any answer? Guys, anybody can answer this question? Which truck I will use in my calculations to calculate the maximum reaction, for example, or the maximum moment, or the maximum shear, or which one I will use to construct the influence line? What do you think? Do you think the maximum, the biggest truck, or the most heavy truck? What do you think? We need to think. Heaviest. Do you know, Benjamin, that probably this small car can make worst case on the bridge more than this biggest truck? Do you know this? Sometimes this little car can make collapse of a bridge that this biggest one cannot. Believe me. So I'm not sure which one can give me the worst one. So what should I do? Okay, we will have another way. This any truck, this one, or 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 any one of them, I will assume this huge truck can be represented by unit load. Unit, one kib, I'm not sure, 1 pound, 1 kilonewton, 1 newton, one watt. What is the unit? I'm not sure. One. It's 1 unit load at the centroid of this truck. So any truck will be converted to a unit load at the centroid of the truck. So right now we have beam supported by hinge and roller, and we have here unit load. That's it. This unit load represents what? I'm not sure. This unit load is representing this truck or this truck or this truck or this truck. No, I'm assuming for general. We have a unit load moving on this bridge from this side to this side. And we need to draw on-flance line due to the effect of this unit load. After you are done due to unit load, after you are done, I can convert this on-flance line to another value or another effect or another on-flance line due to a certain truck. Do you remember we have a problem in math when you are in middle school or high school? I can say, hey, if we have 5 persons, they can do excavation, for example, for 100 cubic yard. Can you tell me if we have 20 persons, how much we can excavate? Do you remember this math problem? Do you remember something like this? If I give you example, 5 persons can excavate 100 cubic yard. Can you tell me if we have 20 persons, how many or how much we can excavate? You can do this one time this one and this one time this one, so you can figure out how much. The same problem here. I will get the on-flance line D2 unit load. So unit load can give you this effect. If you have truck with 20 kib, can you give me what is the effect? I can. Okay, so the next part, we will get or we will draw or we will calculate the on-flance line D2 unit load. However, we have many types of trucks. Later, after we get the on-flance line D2 unit load, later we can get the effect of these trucks. Any trucks, we can do it. Any question? So, Benjamin, we will not use the heaviest one or the biggest one or the smallest one. No, we will get the on-flance line D2 unit load. Unit load is moving from this side to the other side. Once we did this, we can convert this on-flance line due to any effect of these trucks. Any questions so far? Any question so far? If you have any question, let me know. This part of the course, you need 2 things. The first part, you need to understand the concept. It's very important. The second part, we need to understand how to solve. So right now, I'm talking about what is the meaning. We need to understand what is the concept of influence line. Okay. So previously, in the previous part of the course, we learned if you have a correct reaction, you can get a correct solution. That's right? Do you remember? For beam or frame or truss, if you have if you have correct reactions, you will have correct solution. So the first part, we need to understand, we need to learn how can we draw influence line for reaction. By the way, influence lines, I will write it like this. Capital I, capital L. Influence line. So, for example, we have a beam AB. We need to draw influence line for YA. We have another reaction, YB. So we need to draw influence line for YB. Pay attention to me, please. It's very easy to apply this rule. Muller-Breslau principle for qualitative influence line. If you would like to draw influence line for a reaction, go ahead and apply this rule. What is the rule? First of all, move the support corresponding to the reaction upward by a unit displacement. I'm looking for influence line for reaction YA. Go ahead and move this support up by 1. In the direction of the reaction, because one of you will ask me, hey Dr. Ayman, why you moved this support up? Because the direction of my reaction in the positive direction is up. So I moved this support up by 1. Please keep any other support without movement. So the other support will not move. The other support will not move. The resulting deflected shape will be the influence line for this reaction. Can you tell me when you moved this support A up by 1 and this support will remain as it is, the new shape looks like this, line like this. This shape can be called influence line for reaction YA. It's very easy. And I will explain what is the meaning of this one. The value here is 1. Can you help me to draw influence line for reaction YB? Yes, I can. What is the first step? Move. What is the second step? Keep. What is the third or the final? The deflected shape. So the first step, move support up by 1. Which support? We are looking for reaction YB. So please move support B up by 1. So the position of this end is here. Keep the other support as it is, no movement. So the other support as it is. So this end will be remain at this location. What is the new shape of the beam? Looks like this. This diagram is called influence line for reaction YB. Any question? So guys, I told you we need to understand the concept. What is the meaning of influence line? We understand it. What is the meaning of unit load? Unit load represents a real truck, but we converted it to a real unit load. Why? Because we have many types of truck. So which one I'm gonna use? Okay, we will not do this. We will assume unit load. The second part of this topic, how can I draw influence line for reaction? It's very simple. 3 steps. Move, keep the deflected shape. Move the support corresponding to the reaction you are looking for. Keep any other support without movement. The new shape or the deflected shape or the resulted shape will be the influence line. Any question so far? Guys, please respond to me. Any question so far? I would like to be honest with you. This part of the course is the most hard part. If you are asking any structure engineer, he will say the most hard part in the course is influence line. So I would like to make it more easy. So please help me. Pay attention. Okay, I would like to explain to this part or this time to understand something. What is the meaning of this shape? Okay, let's do it here. You draw influence line for reaction YA like this. This value is 1, this value is 0, and you said this diagram called influence line for YA. Can you explain it to me? Yes, I can. Okay. Please pay attention. If the moving load, which is 1 unit, is here. If the moving load, which is 1 unit, is at this location, what is the reaction? What is the value of reaction YA? I think if you take moment at this position and you can figure out the reaction, you will find it 1. So the value here will be 1. What will happen if the moving load moved a little bit here? The value of YA will be 0.75. I did my calculations and I found YA equal 0.75. So I put 0.75 here. Why you put 0.75 here? Because the position of 1 unit of the position of the moving load is here. So I put 0.75 at this location. One more time. What will happen if the moving load is here at the midspan? I found the reaction YA equal 0.5. So I put 0.5 here. Why you put 0.5 here at the same location of the unit load? After a few seconds, the unit load is here. What is the value of YA? I found YA equals 0. So I put 0 here. If you connect between these values, you found you have a triangle. This triangle represents values. We have a value here 0.9. We have a value here 0.1. We have a value here 0.2. We have a value here 0.6, for example. What is the meaning of this value? I can tell you. 0.9 represent reaction at YA if the unit load is here. What is the meaning of 0.6? 0.6 means reaction at YA equal 0.6 if the unit load is here. What is the meaning of 0.2? YA as a reaction equal 0.2 kip if the unit load is here. So this diagram represents many values. These values represent reaction YA when the moving load at this position of these values. In a different way. Guys, if you have a unit load like this, and this unit load is moving from this side to this side, unit load is moving from this side to the other side, what do you think? The effect of this unit load on this reaction, increasing or decreasing? This unit load is moving like this. So the unit load was here, after second was here, after another second is here, after another second is here, after another second outside the bridge. What do you think? The effect of this moving load on reaction YA, increasing or decreasing? I think decreasing. Does that make sense? So this diagram represents something. This diagram, I can say, hey, the influence line, the effect of the moving load is decreasing on reaction YA if this load is moving in this direction. Or when someone different will say, hey, if this moving load is moving in this direction, from right to left, I can say it in a different way. This moving load is moving in this direction, so its effect on reaction YA is increasing. We need to understand what is the concept. We need to learn how to solve. How to solve 3 words: move, keep, the resulting deflected shape. That's it. Let's do it one more time. Before starting, I have a question. If you have a piece of stick, like this one, stick, 1 unit, 1 part, and you put this stick on this support and this support. You can do this experiment at home right now, and I will try to do it next meeting. Guys, what will happen if you move this end up and keep this point as it is? Anybody can tell me what is the new shape of the stick? Please imagine we have piece of wood or piece of stick, and I put this end on this support and this intermediate point on this support. I kept this point as it is, no movement, will remain. And I pushed this end up. Anybody can tell me what is the new shape of the stick? I think the new shape looks like this. Do you agree? Please, if you agree, say yes. If you are not, say no. If you agree, please say yes. If you are not, please go ahead and get any piece of stick at your home right now and try to put the stick between your hands at this end and this intermediate point. Keep this intermediate point as it is, and this end move it up. What is the new position of the stick? Looks like this. We have 8 students. 3 of them responded. So the other 5 should say no, at least. But no response, that means they are cooking for lunch or preparing breakfast. That's right. I received Benjamin, Jennifer, Miguel. That means Carolina did not respond. Clayton did not respond. Kaylee, Marcos, Zach. So what's going on? One more experiment. One more experiment. If you have a piece of wood or stick and you are supporting, you're putting this end on your left hand and this intermediate point on your right hand. Okay, I will do something different right now. I will move my right hand up by 1. So I move this point up. And I will keep this point as it is, no movement. So this point moved up. This point as it is. Can you tell me what is the new shape of this stick? Looks like this. Remember, your stick is 1 unit, not broken. Don't break the stick. The stick is still 1 unit. 1 unit. Don't break it. Do you agree? Do you agree? That makes sense? Okay. So, if we have a beam with another part called cantilever, beam, simple support beam means between this support and this support. With cantilevers, we have external part of the beam. But remember, this beam is 1 unit, 1 piece, 1 stick. If you would like to draw influence line for reaction YA, okay, go ahead and apply this rule. Move, keep the resulting deflected shape. That's it. Move what? Move what? You are looking for influence line of YA. Okay, go ahead and move support A by 1. Keep any other support as it is. The resulting shape, which is looks like this, line, one line, the resulting shape can be called influence line for YB. We have another support here called B. Can you tell me what is the reaction of YB? Yes. Move, keep the resulting shape. Move what? Move the support you are looking for. So I will move support B by 1. Keep any other support. So I will keep this support as it is. What is the new shape or what is the resulting shape of the beam? The beam will look like this. Remember, your beam remain straight line, one piece, not broken. The beam does not be broken. So the new shape will be straight line between the point you kept it and the other point you moved it. This shape, positive in this side and negative on this side, can be called influence line for reaction YB. That makes sense? So we learned something very important right now. If you have a beam simply supported only between hinge and roller, this hinge is A, this roller is B. I taught you how to draw influence line for reaction YA, influence line for reaction YB. Can you remember this? Okay. For YA, I will move this support up by 1. Any other support will remain as it is. Go ahead and connect between the two values. This diagram can be called influence line for YA. Influence line for YB. Go ahead and move support B up by 1. The other support will remain as it is. The new shape of the beam looks like this. This diagram can be called influence line for reaction YB. Just right now, we learned. If we have a beam, remember this beam is one piece, one stick, supported on this hinge or roller, I don't care. And we have another support here. So this beam can be called simply supported with cantilever. What you mean by cantilever, just for your information, this part can be called cantilever. Hanging part of the beam supported from one side and free on the other side. Anyway, so we need to draw influence line for reaction YA. Here is A. And we need to draw influence line for reaction YB. Here is B. Let's start with reaction YA. Go ahead and move this support up by 1. The other support will remain. The new shape of the beam, which is one unit, one piece, one line, will be like this. So this diagram can be called, this value is 1. Remember, this value is 1. This diagram, which is positive, can be called influence line for reaction YA. One more time. Influence line for reaction YB. Move support B up by 1. Keep any other support as it is. Can you tell me what is the new shape between this point that you moved up and this point that you kept it? Will be like this. So the new shape here is 1. This point as it is. So the new shape looks like this. This diagram is positive because it's up. This diagram will be negative because it's down. This can be called influence line for YB. So right now we learn it, I believe. What is the meaning of on-flange line? What is the meaning of unit load? Or what is the story behind unit load? And we learned what is the meaning of this diagram, and we learned how to construct this diagram. 3 words: move, keep, resulting deflected shape. Move, which support that you are looking for. Keep any other support as it is. The new shape or the resulting deflected shape will be called on-flange line for this action. And we learned on-flange line for simply supported beam and simply supported with cantilever, this part. Any question? Any question so far? Okay, I will skip this part, case of fixed support, to do this example. Your problem in the coming exam will be like this. It's not 100%, but something like this. We have a beam. This beam can be called A, B, and we have a point here called C. We need to draw on-flange line for reactions at A and B. And we need to draw on-flange line for shear and the moment at point C and the point C at the intermediate point. Okay, we didn't cover yet how to draw on-flange line for shear and the moment. So please forget it right now, or at this moment at least. Let's focus on what is the on-flange line for reaction YA, what is the on-flange line for reaction YB. Let's do it. This beam, which called A, B, and this end we can call it D, for example. This beam has one reaction here, YB, and one reaction here, YA. I understand that many of you will say, hey, this hinge has horizontal reaction called XB. You didn't mention anything about XB. Anybody can tell me why? Do you have any idea? The horizontal reaction is nothing for me in on-flange line. Do you know why? This horizontal reaction is nothing. Please believe me, it will be zero all the time. Do you know why? Do you know why the horizontal reaction is nothing in this part of the course? Do you know why? Thank you, Marcus. Great job. I will give you 3 points in the coming exam. Thank you. So we have this time. Okay. Benjamin, unit load are only in the y direction. You are good, Benjamin and Miguel, but Marcus, 3 points, and also Benjamin, 2 points, Miguel, 2 points. Marcus, he said exam number 2. Guys, this part of the course is talking about bridge. So we are talking about beam, for example, and we are talking about moving load. This moving load is representing a truck. The weight of this truck is vertical. All the time? Yes, all the time. 100%? Yes, 100%. All the time, this load will be vertical of the truck. So that means the vertical reaction will get a value, but the horizontal one all the time will be 0. Do you think all the time? 100%? Just for your information, it's not a part of our course, but let me ask, do you think when this truck will make horizontal reaction? Do you know when? Do you know when? When the truck will cause horizontal reaction. Do you know when? It's not a part of our course, I know, but just a question. Do you know? No. For one instant, the truck will cause horizontal load. Do you know when? No. When you are trying to use your brake. Because if you are using brake, you have friction between the truck and the bridge. So you have horizontal load. This horizontal load will cause horizontal reaction. Anyway. Let's go back. If you are using your brake of the car or the truck, if your truck on the bridge, and you are feeling you will do accident and you push the brake to stop the car, believe me, this car or this truck will apply horizontal force on the bridge. At this time, we will have horizontal reaction. Anyway. Okay, let's go back. So, can you tell me how can I draw influence line for YA? Yeah, move, keep the resulting deformed shape. Move what? YA, support A, move support A up. If you move this support up by 1, keep any other support. Do you have other supports? Yes, we have. B, keep it. So we have 2 points. One moved up and the other one as it is. Can you tell me what is the new position of this stick or this beam or this piece of wood? I think the new shape looks like this. This side will be positive. This side will be negative. Anybody can tell me what is the value here? I'm sorry, what is the value? Yes, what is the value? You pushed this A up by 1, so this value is 1. Can you tell me what is the value here? Yes, I can. Triangle similarity. Triangle similarity. This triangle looks like this triangle. So I can say this value divide this value equal this length divide this length. That's right. So I think this value will be 0.33. One more time. If you would like to draw influence line for YB, go ahead and push, move, keep the resulting deformed shape. Move B up by 1. Keep any other support as it is. The new position of this beam looks like this. Okay, I agree with you. The value here is 1. Can you tell me what is the value here? This one is 0.33. What is the value here? Triangle similarity. Probably this triangle is similar to the biggest one, so this value will be 1.33. Any question? Any question so far? So any other values except 0 and 1, you can get it by triangle similarity. Any other question? Guys, do you have any other question? Okay. How can I draw influence line for shear and moment? Your moving load, which is 1 unit starting between D, the beginning of the bridge, and point A, the end of the bridge. That's right. Point C that you are looking for intersect this strip between D and A, the beginning and the end of the bridge. Point C intersect this strip by 2 parts. So I will say we have 2 strips right now. The first strip between D to C. The second strip between C to A. One more time. One more time. We are done with reactions. Move, keep, resulting, deformed shape. Right now, we are talking about shear and the moment at a specific point. This specific point will intersect the total trip between the beginning and the end of the bridge to 2 parts. The first part between the beginning to the point. The second trip between the point and the end of the bridge. So assume your unit load is moving from D to C. I will use the other part of the bridge. The other part of the bridge looks like this. We have reaction here, YA. We have cut at C. So we have horizontal load. We have shear. And we have moment. Moment at C, shear at C, and the X at C. Actually, for influence line, we don't care about any horizontal force, so I will cancel it. If you apply summation f of y equals 0, so we have VC plus YA equals 0, so VC equal negative YA. If I take moment at if I take moment at C, assume this direction is positive, so we have MC minus YA times 4 equals 0, so the value of MC equal positive for YA. One more time. The second trip for the unit load between C and A, so the unit load is moving here between C and A. Here is the moving load. I don't like this part, so I will use the first part, which looks like this. Here is a cut. Here is reaction YB. At your cut, we have horizontal. I don't care. We have shear. We have moment. VC, MC. If you apply summation f of y equals 0, so negative VC, positive YB equals 0, so VC equal YB. If you take moment at C, assume this direction is positive, so we have MC negative YB times 4, so the value MC equal 4 YB. One of you will ask me, hey, how can I assume at this cut? How can I assume the shear? Do you remember? Go back to the previous part before exam number 1. For shear, this shear would like to rotate this part clockwise. To assume moment, this moment would like to make this bar to smile. Go back to this part. So guys, we need to do some calculations to draw influence line for shear and influence line for moment. How can I do this calculation? Okay, the first part, your moving load or your truck is moving from this end to this end. Point C intersect this strip to 2 parts. So the first strip will be between D and C. The second strip will be between C and A. If the first strip, if the car on the first part, I will use the other part to be easy. If the truck on the other part, I will use the first part. I set up equation for shear and the moment at C. Shear and the moment at C. This relationship will be used to construct the influence line for shear at C and the influence line for moment at C. And I will continue this example next meeting.